My graduate research focuses on the chemical origins of life, and some of the things that I do towards this goal are to study old historic samples from a scientist named Stanley Miller, who pioneered the field of prebiotic chemistry and published a paper in 1953 showing that you can synthesize organic compounds. In addition to that, I conduct my own experiments where I simulate early Earth conditions and see what types of compounds that we can form that are important to biological amenities. This is important because it helps us understand how biology came to be on Earth. It can tell us about how life arose on Earth and also give us some clues as to how we could potentially look for life elsewhere in the universe, say, for example, Mars. So NASA launched the Curiosity. And so one of the objectives of the Curiosity is to look to see if there's any potential signs of life whatsoever. It'll tell us a lot about where we came from and how we got on this planet. Findings thus far have been from the analysis of original samples that Stanley Miller created, have been that you can get not only simple amino acids that he first published on in 1953, but that you can get larger, more complex, sophisticated biological compounds under simulated plausible prebiotic conditions. The objective of this work was to understand how can you get larger, more complex molecules as opposed to just the simple ones. I decided to come to Georgia Tech because there were a lot of opportunities for me to collaborate with faculty members here and graduate students here, and also that type of camaraderie could help me build a network of individuals that I can collaborate with in the future.